just general questions and tell you a little quickly about myself, and then we'll get going, because I know you have other things too. Are you seniors? Juniors?
Master's program.
Mixed group? All in teachers in training, right?
Yes.
Okay. All right. Well, my name is Mr. Love. I'm not really a doctor, by the way. That was kind of given to me when I was teaching at Valley Central. One of the teachers there started calling me Doctor of Love, which I didn't really like too much. But what caught on was Doc, Love, and then I just became known as Doc. So my role right now is to help Bishop Dunn kind of revitalize their science program, and to help Dr. Spirinova train you in the area of science and scientific method. I taught for 37 years at Valley Central. My specialty is physics. I say, oh, that's what I usually get. And then 7 years I was an adjunct here, also teaching physics. And got a call from Bishop Dunn, and they've been wanting for quite some time to revitalize their science program. So we've been working pretty hard for 2 years to do that. And one of the big things that they do is the scientific method and science fair. And in fact, not only the students doing the science fair, but I understand that you're going to be doing science fair projects also. I was there last year as they presented both the Mount students and students from Bishop Dunn. And what I noticed was a uniform problem that both the students at Bishop Dunn and the students at the college had in using the scientific method. And we all agreed that that wasn't good. At least in the area of Bishop Dunn, they'd like the students to compete even at a higher level at some regional science fairs and so on. But in order to do that, you have to use this method properly. And it really isn't understood, all the different aspects of it, and has not been uniformly used correctly. So what I've done is I put together a packet for you, and I have a PowerPoint presentation to go through, and I'll try to do it. I want to do it so quickly that you don't absorb it, and I'll pause every once in a while to see if you have questions. But I know you have other things to do, so we'll keep things moving along. Do you have any questions to start with? Okay. So it says universal standard of investigation. I put their clicks. Oh, do not to turn it on, don't I?
Yes.
Yes, that is one basic thing. So it starts off with this question. Like so many, I don't like doing anything, using anything, unless somebody can tell me why I'm doing it. What is the purpose of this? What's the purpose of the metric system? What's the purpose of scientific notation? What's the purpose of the scientific method? So let me start by asking you. Other than science uses it, is it just a tool of science? If it is, why is it so important? Do you want to have any ideas?
Tool of inquiry.
Okay? It's a tool of inquiry. So it does go beyond science. Anytime you're investigating a problem, a detective investigating a crime, or trying to follow the facts where they lead, it's a logical series of steps that allow you to move through the process. So it's fundamental. It's not just a science phenomenon. So you correctly said that. Again, this is more specialized to science, but that's what it is.
Like I just taught this today.
You just taught it today, so, okay, so that's good. And I know at Bishop Dunn, they're starting in the same place. They're starting with the scientific method, going through some of the basics, metric system, make sure everybody's on the same page. In fact, tomorrow we're going to be doing a conference at Bishop Dunn, and this is one of the topics, to make sure that all 28 teachers, as they prepare their students for the science fair, are understanding and using in a uniform way this, or is age appropriate, and so on. There's a flow chart that pretty much shows what the different aspects of the scientific method are. It starts with a question, and often that question is based on previous research. You formulate this thing called a hypothesis, and then you do something very important, great. This is really the heart, the soul, the core of what the scientific method is all about. So we're going to spend some time there. And of course, that generates data, results, and a lot goes on in analyzing that data. So you kind of hit pause, and depending on the amount of data that you receive, you have to go through that process of bringing statisticians in and anybody that helps us to put the data in a form that's meaningful. And there's usually presentations and everything else. And then comes the conclusions. And in real science research, and we're gonna do a pretend one here in just a moment. It's not a one-time shot, you know. So the conclusions that you leave, you're leaving a roadmap for someone else to follow to do the next round of experiments, usually at a higher level, a level up. So as you begin the research, there are some basic questions that you need to ponder. And we'll kind of unpack these and unravel these as we go through. Control and experimental groups, a very important part of testing your results. What are they? Why are they important? Why are they important to identify? Why are they important to articulate? What's the difference between an independent and a dependent variable? What does that have to do with the control group and the experimental group? And then, what results would you predict with each group? Yeah, you anticipate, not conclude, you anticipate that this may happen to the control group. This may happen to the experimental group. Often you're surprised. That's not a bad thing. That often leads to more inquiry. Okay, so I found over the years, the decades, I love saying that because you can see that I have decades here. The best way to really get students involved in this is to imagine a scientific experiment, to imagine with you a project. So let's do that. Let's pretend that we're part of a pharmaceutical company, and we have our group, which is made up of 20, 30, 40 people, is primarily charged with investigating medications, drugs for skin cancer. Our team's been together for a long time. We have biologists, we have chemists, we have statisticians, we may have computer experts, we may have physicists, you know, we have the full range. We're kind of self-contained in terms of knowledge. And so it all begins with a problem. Usually that problem is given to you by a boss. The boss calls you in, says, hey, you know what? The chemists have come up with a slight variation of the molecule that we tested a few years ago on skin cancer. They moved a few atoms around, and they said this it may make a difference. It may, you know, the difference between water and hydrogen peroxide is 1 oxygen. So, you know, just adding a molecule, an atom here changes the whole structure. So my boss puts that chart before us, says, here's the information that the chemists have, here's the molecular diagram, here's the chemistry behind what we have, and take this to your team and put together a proposal, come back to me, and off we go. So, we gather as a group, I introduce the problem, I put the molecule on the screen, I provide all the background information of what happened last time we used a similar molecule on skin cancer. I answer questions, people have different input, and then the time arises where we have to put together a hypothesis. So, what is a hypothesis? Educated guess, right? What's the difference between a guess and an educated guess?
A guess could be anything. You could be like, watermelon.
Yeah,
But an education